Last time, we were looking at the orange juice recipes and trying to scale up each of those mixes so that there was enough juice for all 120 people. In this video, we're going to examine that strategy and then get ready to apply it in order to solve lots of different problems the same way. To begin, let's take a closer look at what we discovered for just mix A. Of course, mix A requires us to mix together 2 cups of concentrate and 3 cups of water. Mix those together, 2 and 3, you get 5 total cups of juice. We've been practicing writing ratios, so let's write a ratio that represents mix A. We know that we can compare 2 cups of concentrate in a total of 5 cups of juice. There's a ratio that shows the original recipe, and it's a special ratio. You guys now know that that is called a part to whole ratio because we're comparing the part of just concentrate compared to the whole total cups of juice. There's the original recipe. We then scaled that up and we found that we would need 48 cups of concentrate in order to make a total of 120 cups of juice. Now we've got 2 different ratios. Again, the first one was the original recipe. The second one is going to taste the same, it's just scaled up so that there's enough for everyone. It's the same juice, it tastes the same, which tells me that these 2 ratios are equal to each other. See how I just threw an equal symbol in there in between them because I know that those 2 ratios are equal. And we have a special word for 2 ratios that are equal. We're going to call that a proportion. Again, a proportion is when you just have 2 ratios that are equal to each other. You are going to need to know how to set up and solve proportions in order to find answers to lots of different problems. Let's take a look at one word problem where we are going to need to set up and solve a proportion for. It's a very important word problem. It has to do with how quickly you can eat hot dogs, the most relevant thing that you all need to know about yourselves. Here's the word problem. It says Mika can eat 6 hot dogs in 8 minutes. How long will it take her to eat 36 hot dogs? We're going to set up and solve a proportion for this. But before we even get into that, let's take a closer look at the word problem and pay attention to the important information to ask ourselves, what is being compared? Well, in that first sentence, I know that we're comparing how many hot dogs she can eat in the number of minutes. So 6 hot dogs in 8 minutes. That's a comparison. Let me color code those because I'm paying attention to I'm comparing hot dogs versus minutes. In the second sentence, the question there, I know that she can eat 36 hot dogs in how many minutes? Let me underline that with a squiggle because I'm going to clue myself in. That's what I'm looking for. That's the answer that I need to find. All right, now that I've pulled out that important information, I know what I'm comparing, I can put it into a proportion. So first, I know she can eat 6 hot dogs in 8 minutes. So there's my ratio, comparing number of hot dogs versus number of minutes. Since it's a proportion, I'm going to write an equal symbol. And then, of course, I'm going to write my second ratio. Well, she can eat 36 hot dogs in how many minutes? I don't know yet, so I'm going to throw a question mark right there. All right, so now we've set up the proportion. And before I solve it, I've got a question for you. Could I have set up the proportion differently, like this, where I compared number of minutes versus number of hot dogs? The answer there is no. If over here I'm comparing the number of hot dogs versus the number of minutes, then over on the other side of the proportion, I better be making the same comparison, hot dogs versus minutes. The order matters, and I hope when I color code, it helps you see, oh yeah, I'm comparing hot dogs versus minutes. All right, now let's solve this proportion. And what you might find is that it's sort of pretty similar to our work that we are doing with scale factor. We're going to ask ourselves, how many times bigger is that ratio getting? If at first she ate 6 hot dogs, now she's eating 36 hot dogs, how many times bigger is my ratio getting? Well, I know 6 times 6 is going to be 36. So that ratio is getting 6 times bigger. I'm going to need to do the same exact thing to the denominator. So I'm going to find 8 times 6 again is going to tell me the number of minutes. 8 times 6 equals 48. So I know that she can eat 36 hot dogs in 48 minutes. And I just solved that through a proportion.